We can also use the tangent ratio to calculate the lengths of unknown legs of a triangle. Legs are just the same as sides, the unknown or not known sides of a triangle. We use indirect measurement to calculate missing lengths instead of using direct measurement. Direct measurement is physically measuring something, taking a ruler or a set of calipers and measuring something. Indirect measurements are useful when the lengths we are trying to determine are very large. This next box says, it is often convenient to use the lowercase letter to name the side opposite the vertex of a triangle. So as you can see here, we have an angle B or a vertex B. Across from that, we have a lowercase b. Angle C, lowercase c. Angle A, lowercase a. That's all this is saying. Often you'll see a triangle with angles where they're capitalized and sides that are lowercased. Okay? Let's take a look at our example. To determine the length of xy to the nearest tenth of a centimeter. So we have to find our side xy right here. We have tangent. We have an angle here of z, which is 70 degrees. Tangent is opposite over adjacent. If we take a look, opposite here for that angle is xy. Adjacent, remember this longest side is our hypotenuse. Sorry, I'm going to clean that up a little bit. That is the hypotenuse. So our adjacent side is zy. I can plug numbers in here. So my tan of 70 degrees equals xy over 5. I'm going to multiply both sides by 5 so that they cancel. Okay, so I end up with xy equaling 5 times the tan of 70 degrees. Plug this into my calculator. 5 times the tangent of 70 ends up being 13.7 centimeters because this says tenth of a centimeter. This is a tenth of a centimeter. That's my final answer, so I'm going to put a box right around that. All right. This is a great time if you would like to pause and try on your own. So that's my suggestion. So try example number 2 on this page on your own. I'm going to continue to work through it for those of you that want to work along with me. If you don't, you can fast forward and find the answer and see if you've done it right. So let's take a look. Determine the length of Vx to the nearest tenth of a centimeter. So we have an angle here of 42. So I'm going to use my tangent ratio for 42 degrees, which is opposite over adjacent. Opposite in this case for my angle is 7.2 centimeters. Adjacent is our Vx. This is VW here is my hypotenuse. I know that because it's the side directly across from my 90 degrees. So hypotenuse is always across from the 90 degrees. All right, we're going to solve for Vx. In order to do that, I'm going to multiply both sides by Vx. So that cancel Vx. Okay. I'm going to divide again just to keep Vx on one side by itself. Divide by the tangent of 42. So I end up with Vx equals the 7.2 centimeters over the tangent of 42 degrees. Okay. When I plug this into my calculator, I end up with approximately, or about, 8.0, that's a 0, centimeters. Because it says a tenth of a centimeter here, I have to include this decimal 0 in my answer. But that is my final answer, so I'm going to put a box right around that. All right, example number 3. At a horizontal distance of 200 meters from the base of an observation tower, so this is our tower right here in our diagram. This is our tower. The angle between the ground and the line of sight, so line of sight is our hypotenuse on this angle. Imagine you are a person standing right here. This is what you would look at, your angle to looking at the very top of this observation tower. So the angle between the ground and the line of sight to the top of the tower is 8 degrees. How high is the tower to the nearest meter? So we have tangent, because that's what we're working with. We have our angle of 8 degrees. Our opposite, which is our unknown, let's say h for height, over adjacent. Well, do we know adjacent? Let's take a look at the question again. A horizontal distance of 200 meters from the base. So I know that it's 200 meters from where you're standing as the person to the actual tower. So that's my opposite is h. My adjacent is 200. Plug those two in. I want to get h on its own, so I'm going to multiply both sides by 200 meters. That cancels. 200 meters on the other side. I end up with 200 tan 8 degrees equals h. Okay. When I plug that into my calculator, I get h equals 28 meters. And it says to the nearest meter, so that's perfect. I'm going to put a box around that, and that example is finished. If we take a look at our last sentence on this page, we see students commonly use TOA, all right, where TOA is tangent, opposite, and adjacent, to represent that when they use the tangent ratio, you take the opposite and divide it by the adjacent sides. All right? Also remember just that anytime you're looking for an angle, you're always using, when you look for an angle, you need to use that tan to the minus 1 or inverse function. Okay, so that's just a final reminder. All right, on to the next lesson.